So now in this video we're going to look at one of my favorite components really quickly. So this is the LM334. What it is, you can see it's 3 terminals. It looks like a transistor. The ones I have are in TO92 package, and based on the resistor that you use here, it will have a certain amount of current flowing through it. And of course, any series components will have that same current flowing through them, as long as you got enough voltage to power everything. So it can go up to 40 volts, but it has a 400 milliwatt maximum power dissipation, and so you got to keep track of how much voltage is across it, how much current it's limiting, basic power formulas, so that you don't overheat it. So the more load there is, the more voltage you can safely use at a higher current. But in any case, you can go down to 1 microamp or up to 10 milliamps. So 1 milliamp, I need a 68 ohm resistor. If I want 10 milliamps, I would need to use a 6.8 ohm resistor. And here I put the math. You can see the other end of the spectrum. If I use a higher value resistor, 10 times the resistance, we'll get 1/10 of the current. So the current is linear with the resistor that you use here. If you double the resistance, you'll get half the current, and so on. So now, over here, I have the LM334. I have a 68 ohm resistor from this packet there, and I have a 680 ohm resistor from this packet here. Really straightforward. We have the pin layout right there. So V plus is the left pin, R is the middle pin, and V negative is the pin on the right. So if I swivel it this way, now V plus is top, R is in the middle, and then V minus is down there. So flat side facing to the left. I'm going to put that to the positive rail. We could build it on this side too. Doesn't matter. We're going to grab the 68 ohm resistor first. So we should have about 1 milliamp of current going through the component once power is applied. And we're going to fill this gap with a multimeter to measure the current. So there we got the multimeter. So we're going to set it to measure milliamps. The red probe stays there unless we measure high current. So this is an auto ranging meter, but when it comes to current, you gotta pick the range a little bit more than the other options. So now we just complete the circuit right here. I have the power supply set to 5 volts, by the way, and there you can see we got 1 milliamp of current. So if I grab a green LED here, you're going to see that it should still be 1 milliamp of current, even though we just changed the load. There we go. It did pretty good. So as I said before, we're dealing with 5 volts, and so this is too many LEDs. It still actually did fairly okay. Red LEDs don't get as bright at 1 milliamp of current, but in any case, we just have to up the voltage. And so hit select there. Let's just go right to 10 volts. Why not? And in any case, you need whatever voltage you need to power both the load and the LM334. There we go. So we just doubled the voltage and we're back to 1 milliamp of current. Pretty straightforward. So that was with the 68 ohm resistor right there setting the current. Now let's go to the 680. So 10 times the resistance will get 1/10 of the current. So you can see it's about 0.1. Okay, it's saying 0.1, pretty good. We can set the meter for microamp for a more accurate reading, and it should be 100 microamps, which is the same as 0.1 milliamps. So that worked out well. Again, we have 10 volts, so if we change the load quite a bit, we got an LED now and another one. They're not going to be bright because we're only dealing with 1/10 of a milliamp. You can just barely see the red one glowing right there, but her current's holding steady. That is the main thing. Now it doesn't matter, we're gonna shuffle both of these components down. whether it's on the more positive or the more negative side right there. The component has to be inserted in the right direction, but now we can measure the current up here, and there you can see current is the same. And we will change the load again. Of course, LEDs, you have to put them in the right direction. Anode, the long lead, towards the more positive side. Cathode, the short lead, towards the more negative side. But you can see we work our way even on the positive side. You have the current right there. So it's a really cool component. I use it wherever I want a real simple current source that doesn't take up much space on the breadboard. So there's other ways to make current sources that these cost about $1 each, so not terrible, but you may not want to buy a bunch of them at $1 each, and you have to make a current source with other circuitry. But for just starting out, for demonstration videos where I just want to show how something responds to a current source, this reduces clutter and simplifies things. So it's one of my favorite components. You'll see it quite a bit in my videos. So in any case, I'll post some other videos to the screen. Make sure you check them out. Click subscribe, like, the bell, and all that good stuff. I will see ya in the next video.